Dear students, very good afternoon. Now we are going to see the problems under Cauchy Integral Formula. So we have to know the formulas very well. Okay, we have to know the formulas very well. Then only it is possible to solve the problems using Cauchy Integral Formula. So Cauchy Integral Formula. Okay, so in the previous video we have written two topics. One is Cauchy Integral Formula, another one is Cauchy Integral Formula for derivatives. Now I would like to recall only one formula here, that is integral over C f of z divided by z minus a whole power n plus 1 whole power n plus 1 dz equal to 2 pi i into f power, that is entire derivative of f power n of a divided by, or 2 pi I divided by n factorial. Okay, 2 pi I divided by n factorial into f power n of a. This one formula is alone to solve entire problems on the Cauchy Integral Formula, because if you want to find if n equal to 0 means you will get the Cauchy Integral Formula for ordinary functions, that is for non-derivatives, that is for zeroth derivative. Okay, that is f of a by z minus a whole power 1 dz means here n equal to 0. 0 factorial is also 1. So 2 pi I into f power 0th derivative of a. So f power 0th derivative of a is f of a. So 2 pi I into f of a. Okay, 2 pi I into f of a. In the same way we can find first order derivative, second order derivative. If I put n equal to 1 here, I will get first order derivative. If I put n equal to 2 means I will get the second order derivative of f power n of a. Here you will have, for first order derivative you will have square, for second order derivative you will have cube. Okay, so the only one important formula is this. This is very important. Okay, okay, now we shall move on to the problems, but before moving into problems, I also like to tell one difference between Cauchy integral theorem and Cauchy integral formula. Okay, both the statements are almost same, but in Cauchy integral theorem we are not speaking about the point A, whereas in Cauchy integral formula we are speaking about a point A. Okay, but while doing the problems we able to see the denominator is in the format of z minus a. If that a lies outside the circle, then the f of z is not analytic at that point, but fortunately the points other than the point on a is lying inside the curve, so we can say f of z is analytic inside and on C. Therefore interval over C f of z dz equal to 0. Okay, so here we are speaking, here we need the denominator points to be outside. If it is inside means it automatically will become 0. If it is outside means the points will be analytic except at a point. So we have to compare it with the given circle. So after comparison we can tell interval f of z dz equal to 0. But here we are considering only the points z equal to a to be inside the curve. If only a lies inside, we can get this value 2 pi I into f of a, that is interval over c f of z by z minus a dz equal to 2 pi into f of a can be used for the functions, or otherwise you can use for derivatives, you can use interval over c f of z by z minus a whole power n plus 1 dz equal to 2 pi I into f power n of a. You can make use of this. Okay, so I have told you the difference. Now we shall see the first problem. Okay, the first problem is evaluate. The first problem is evaluate integral over c z by z minus 2 z by z minus 2 dz, where c is given by, where c is the circle given by modulus of z equal to 3, where c is given by modulus of z equal to 3. So we can expand this. Modulus of z is root of x square plus y square, that is x minus 0 the whole square plus y minus 0 the whole square equal to 3 square. Center is 0, 0. Radius is 3. So we get the following circle: c of 0, 0, c of 0, 0. Now I have drawn this circle. The radius is 3 means here it will be 3, here it will be minus 3, here it will be 3, and here it will be minus 3. So this circle equation is modulus of z equal to 3. Then definitely this z minus 2 equal to 0 will become C solution. Here z minus 2 equal to 0. Z minus 2 equal to 0 implies z equal to 2. This z equal to 2 lies inside the circle modulus of z equal to 3. Lies inside modulus of z equal to 3. So this is A. See, this is A. So what is f of z? So we can write f of z equal to z A equal to 2. C is given by C is given by modulus of Z equal to 3. So by Cauchy's integral formula, by Cauchy's integral formula, by Cauchy's integral formula, integral over C f of z by z minus a dz equal to 2 pi I into f of a. See, our f of z is z. Our f of z is z. Our f of a will be a. I have to replace this z by a. Okay. So what is a for us? In our problem, the value of a is 2. In our problem, value of a is 2. That is f of 2 equal to 2. So we can write for our problem f of integral over c z by z minus 2 dz equal to 2 pi I into f of 2, that is equal to 2 pi I into 2. So the answer is integral over c z by z minus 2 dz equal to 4 pi I. 4 pi I. 4 pi I. So here completes the first problem. Here we have completed our first problem. Now we shall move on to the second problem. Here we shall move on to the second problem. The second problem is okay. So under this section we will have some 2 marks, or even sometimes you will have 7 marks. Okay, not sometimes. This section is equally having 2 marks and as well as 7 marks. Now we shall see one important problem. The second problem is given by integral evaluate integral over c dz divided by z e power z, comma, where c is modulus of z equal to 1. Okay, now the idea is the denominator should be in the form of z minus a. So we have to make all our functions to be in the numerator. So the solution will be given by, solution is integral over c dz divided by z e power z equal to integral over c e power minus z divided by z minus 0 into dz. Okay, z minus 0 into dz, z minus 0 into dz. So here f of z equal to e power minus z. Okay, and z minus a, from z minus a we can tell a equal to 0, therefore f of a equal to f of 0 equal to e power minus 0 is 1. Okay, then we have to verify whether f of z is analytic inside or not, and also we have to check whether this a lies inside of the circle or not. They have given modulus of z equal to 1. So modulus of z equal to 1 means, see, it is not necessary to write all the time x square plus y square, x square plus y square. By our experience we can easily know if it is modulus of z equal to 1, the center is 0, 0 and radius is 1. Okay, this is center 0, 0 and it is radius is 1. If then the cover will, the circle will come up to minus 1. In the y axis 1 and in y axis will have minus 1. Okay, this circle is modulus of z equal to 1 and this z equal to 0, z minus a equal to 0, so z equal to 0 also lies inside. See, z equal to 0 lies inside modulus of z equal to 1. Therefore f of z is, you have to write it, f of z is analytic. What are two conditions? F of z is analytic inside and on C. You have to write statement itself. Inside and on C you can write. Also A is the point lies, okay, just a minute. A is the point lies within C. A is the point lies within C. Lies within C. Therefore by Cauchy's integral formula we have, what is Cauchy integral formula? Integral over C f of z by z minus a dz equal to 2 pi I into f of a. Therefore integral over C e power minus z by z minus 0 dz equal to 2 pi I into f of 0, that is equal to 2 pi I into 1, that is equal to 2 pi I, that is equal to 2 pi I. Okay, that is equal to 2 pi I. Okay, so This is the solution of this second problem. Okay, now on another video we shall discuss the problems related to combination of many z minus a's, or the denominator will be in the powers of z minus a. Z minus a will have multiple powers, z minus a square, z minus a cube, or z minus a1 into z minus a2. There will be some combinations, so we shall discuss those problems. And also not only for circle, we will have problems on ellipse also, because ellipse is also a closed curve. So we shall discuss all those things on our upcoming videos. Okay, thank you all for watching this video.